Right. So let's just do a very quick recap. Okay, what we learned about forces. We know that a force is either a push or a pull, right? Right or not? Yeah. So it can actually cause a few kind of changes, a few effects. Like for example, it can make something that is not moving start to move, right? It can make something move faster. It can make something move slower. It can even stop the movement of an object that is in motion, right or not? We learn all this, right? So it can also change the direction of movement, okay? It can change the shape of the object as well. This is what we have learned about forces. And we learned about a few kind of forces. We already are very familiar with magnetic force, right? Yes or no? Then we talk about gravitational force also, isn't it? The pull of gravity. Then we talk about friction. Yes? And what is another one that you need to know? What is another one? Anybody want to try? Okay, what do I have in front of me? What is this? What kind of force is this? Do you know what I have in front of me? Hey, this is a rubber band. You see,
rubber band.
I can pull all the way, right? So when I pull, imagine you're pulling the rubber band. How do you feel?
Is it elastic force?
Yeah, elastic force. That's right. Who said that?
Gregory.
Gregory, yes, this is the elastic force. And we talk about spring also, elastic spring force, but you can generally call it elastic force. Okay, so this is another one you need to know. Okay, so very quick recap. These are the few that we have covered. And very often they like to ask questions on magnetic force, okay, and then the frictional force. Later you will see the questions, right? Today I included extra questions. Okay, and then also the last lesson, right? I also mentioned, okay, somebody, Rose, you said elastic potential energy. Remember the last lesson, I also mentioned, don't mix up energy with forces. Yes or no? I think I mentioned that, right? So can you write down somewhere? Okay, never mix up forces and energy. They are two different science concepts. Clear? Don't mix them up. When we do energy, I will emphasize a bit more, okay? But tentatively, all right, that is not the elastic potential energy that I'm talking about. Okay, I'm talking about forces, so it's the elastic force. Okay, usually we talk about elastic spring force, something like that, okay? So I'll go on. Now, you have watched the video. You have done your worksheet. So very quickly, I need you to help me to do this questionnaire. Remember last time I asked you to type in, right, in the chat box. Okay, so we will not practice that now. I am actually doing this for tracking your progress also. So I'm going to see what kind of responses you key in for me, and I'll be tracking it along the way, right? So I can roughly see how much you have improved or what kind of help you need for our lesson. Maybe I should also put it inside the chat box. Okay, control. Okay. I put it in the chat box also. For those of you who are not using the QR code, I don't want you to be typing in. Okay, it's pretty long, so you can copy from the chat box. You must put in your full name also. I only collect your full name as well as your responses, nothing else. Right? That's fast. Okay, thank you, Ange. Now, this is where you can also key in. I mean, at the end of the lesson, you'll be keying in another form. Okay, so that is where you can also tell me what you would like to have for the following lessons. Okay, so before and after all the questionnaire, right, all the forms that I asked you to fill in, you can write down what you will wish me what you wish to see in our classes. So I did receive responses from Sec 1. Okay, students are asking for more difficult questions. Okay, and then I agreed to bring in some questions, like every at the end of every lesson, at least one long question to go through with them. So you can likewise ask me for this kind of questions also. Okay. Okay, 5 of you already submitted. That's good. All right. Okay, I'm waiting for 2 more. Okay. Force can be push or pull, elastic force, potential energy, and forces are not the same, okay? Right, difference between forces and energies, okay. Right. Somebody asked, is force only push or a pull? Now, forces, we talk about contact and non-contact. Right now, remember? Okay, non-contact will be things like gravitational. It's like it's a pull. Yeah. Some forces need contact. Like when I push a ball, I need to touch it, right? If I don't touch it, no contact, it can't happen. Friction, it only happens when two surfaces are in contact. Okay, so this is how we define. Generally, it's all about push or pull. All right. So at your level, it's fine. You can just say that, yeah, forces, we only talk about push or pull. Why is it that the globe theoretically spin? Interesting.
I mean, how a the Earth globe theoretically spins.
Theoretically spin. Is it?
Yeah.
Okay. We address this another time, okay, because this is not part of our content. We have to finish off all our work first. Then
gravitational force and all that, and gravity and all that under forces part.
Thank you, Gyatso. You're very, very interested in science, right? Wonderful. Gyatso, I can't see your face. Ian, I can excuse a bit. He's really unwell. Usually, Ian will show the whole face. I know. Gregory also. Okay, Julian as well. Only see half your face. Gyatso is the least. I only see your hair. Yeah, okay, better now, Julian. Thank you so much. Okay, so now, right, this video is a very general one to talk about the fossils that are around us. Okay, I think I don't want to show this. Instead, I want to show you something else. So I'll stop share first. Okay, or I can open up from here. Right, while y'all are waiting, you can watch also. Remember, I did tell you about videos showing how astronauts actually play games in space. I promise you that I want to show you, right? Okay, this is actually really interesting. Okay, and it's good to know how astronauts actually function in space. Okay, let me play this first.
Things in space look a whole lot.
I'm going to share this. Just give me a few seconds.
Things in space look a whole lot cooler than here on Earth. Welcome back, guys. Today's video is on the top 5 amazing space experiments.
How do you wash your hands with soap and water in space?
Number 5. Canadian astronaut Chris Hadfield experiments with a new pack of hand washing solution and demonstrates how to properly wash your hands in space.
It is no rinse body bath. No rinse body bath. And it's a bag with a straw. So now let's demonstrate. Okay, it's time to get clean. I'm going to squirt some water out. So we have a big ball of water, and you put it on your hand. And now I've got water floating around on my hand. And so I wash my hands up with that. And then grab a towel. And dry them off. So that's how we do it. We use no rinse. It's a special type of slightly soapy water, so you don't need to have a bunch of fresh water afterwards. You squirt it, you float a ball of water in front of yourself, and then you just dry your towel. And when you're done, we just tuck our towel somewhere to let it air dry so that the evaporated water gets back into the space station and we can use that water again. So it works pretty well. Sort of like, maybe sort of like if you were on a sailboat and you needed to get clean, you do it sort of the same way.
Number 4. An astronaut experiments with water physics in a weightless environment. It's really trippy to see how the water reacts.
Wow. Cool. Wow, I just love those oscillations. Here we go. Okay. Let me switch it to a black background. Yeah, so that's about 800 mils. So this should put it around 1100 milliliters. Let's see what happens here. Oh, I just love that. Look at that. Amazing. Just one of these jaw-dropping moments. Okay, here we go to do it again, looking into the camera. Big buff. Here we go. Oh, right at the lens. I saved the lens. What I'm planning to do is, after this whole series of experiments, I'll suck all this water up with a syringe, I'll put it back in bags, and I'll use it to make tea with, so I'll end up drinking my experiment. You gotta conserve your resources when you're in a frontier. You don't get to see this as common, intuitive observables on Earth. And so when we go into a frontier, our normal Earth-honed intuition no longer applies. And this rule works in space, and I can't. And instead of putting a puff of air on it, I'm going to put a puff of water. This is going to have a lot more momentum in it than the air. Whoa, whoa. I was afraid. Oh, look at that. Cool.